Hello everyone, my name is Tom Dow and I'm a Senior Solutions Engineer at Lightbitslabs. In this video, I'm going to show you how Lightbits can be used as a backend storage in an OpenShift environment. You may be wondering what Lightbits is and what it does. Well, for starters, if you're looking to modernize your OpenShift environment with high-performance backend storage, then this video is for you. Everyone knows that OpenShift supports most storage vendors today, but not all storage vendors are the same. If you run latency-sensitive applications on OpenShift and not use high-performance backend storage, you could experience application timeouts. Here's the agenda for this demo. First, a quick overview of the Lightbits product. Then we'll get into the demo on how to set up Lightbits as a backend storage for OpenShift. Lightbits is a software-defined storage solution that uses nvme over TCP, which was also invented by Lightbits. You may have heard that most storage vendors are starting to support nvme over TCP in their product portfolio because the technology is cutting edge and high performance with reduced deployment costs. The Lightbits software-defined storage solution provides enterprise-grade features for your critical applications running on OpenShift and OpenShift-V. You see that we not only provide the OpenShift and open source Kubernetes CSI driver, but also the drivers for OpenStack and VMware vSphere as well. Okay, let's get into the demo so you can see how Lightbits provides persistent storage for OpenShift virtual machines. Here is my current testbed. Because I'm using a non-production environment, my OpenShift cluster will be on a single node setup, and my Lightbits cluster will also be on a single node. Alright, I'm logged into my client server that I will run all OpenShift commands to manage my OpenShift cluster. Here's my current cluster nodes. As you can see, I have only installed a single node OpenShift cluster. To use Lightbits as a remote storage, I need to install the CSI driver. Installing the Lightbits CSI driver is simple. First, download the CSI driver onto the provisioner node. I'm going to use the curl command to do this. Now, let's extract it. The CSI driver is in the K8 directory. The file we want to install is the lbcsi plugin k8v1.24-dc.yaml file. I'm going to install the CSI. Let's verify the installation. We should see the CSI controller and the CSI node running. Okay, next step is to install the secret and the storage class. These files are in the examples directory. Lightbits provides some examples to test the CSI driver, but you don't have to use them. What I usually do is separate the secret and the storage class into their own files. As you can see, the contents for the secret and the storage class are in the same YAML file from the tarball. I am going to create a new file for the secret and another one for the storage class. Now, before applying the secret file, I need the JOT token to access my Lightbits cluster. To do that, first I need to convert the JOT token of the Lightbits cluster to base64 format. Then I'll copy the output to the secret file. The next step is to change the storage class file with the correct endpoint IP address of my Lightbits cluster node. I also need to change the replica count, compression, and project name as well. One thing to note is that you can have multiple storage classes, with each has its own parameter settings to fit your workloads. Okay, let's apply the secret and the storage class files. Okay, let's verify the secret and the storage class. There's the secret. And the storage class. Now let's run a quick test to create a PVC to make sure that it works. But before that, I'm going to create a new project first. Okay, let's log into the Lightbits cluster to verify the volume has been created. There it is. Now, let's go ahead and create a pod. Now let's log into the pod and see if we can see the physical volume. There is our 10 gig volume. Now we know the CSI driver works. We can delete the pod and the PVC and proceed to creating VMs and see how that works. I have already created the YAML files for my VM, so I'm going to use them. Basically, I have 3 step files. First, create a data volume as a boot volume for the VM. You want to wait until the data volume has been created successfully before moving to the next step. Second, I am going to create another PV to run FIO. Let's check the Lightbits cluster to make sure we see 2 PVCs. And there they are. Now, let's create the VM. Okay, now let's take a look at the console. Click on Virtualization, go to Virtual Machines. There's the VM, and it's starting. Now it's running. we can check the storage too. So let's go to the storage, click on persistent volume claims, and there are the two PVCs. Alright, now let's log into the VM and use FIO to write to that volume. Let's get the IP address of that VM. Okay, let's see if the volume is there. And yes, it is. Now we can install FIO. Okay, let's do some writes to it. And that concludes our demo. You can go to lightbitslabs.com for more information about our software-defined storage solution. And thank you for watching.